Good evening. I welcome you all for the today's session, Logic Gates. So now in this session, we are completely going to study in the second unit. We are completely going to study about combinational circuits. So the difference between combinational and sequential circuit is your combinational circuit depends, your output depends on your present input, whereas in your sequential circuit the output depends with both present and previous inputs, right? The examples for combinational circuits are adders, subtractors, multiplexers, demultiplexers, encoder, decoder, etc. And for sequential circuits, all memory devices like flip-flops, registers, counters. Hope you are clear with combinational circuits and sequential circuits. So before going to the adder designs like design circuits like adder, subtractor, multiplexer and all, we should know about logic gates. So what is a logic gate? It is an electronic circuit which makes logical decisions and allows the combination of digital signals present on its inputs. So for this inputs to bring the specific output, we are using this common basic logic gates. So these are all the types of logic gates like AND, NAND, OR, NOR, NOT, XOR and XNOR. So totally we have 7 types of logic gates. And also we have certain universal gates that we will discuss after discussing about each gate. We will discuss about the universal gates. So first, AND gate. AND gate is an electronic circuit whereas your output is high only if both the inputs are high. If any of your input is 0, that is low, your output will be low. If both the inputs are high, your output will be high. So in this truth table, you can see two variable truth table. In all first three like 0, 0, 0, 1, your output is 0. And in the fourth place, like both the inputs are high, your output is 1. This is all about your AND gate. Okay. Next, OR gate. OR gate is if both the inputs are low, your output will be low. If any of your input is high, your output will be high. Understood? So it is like AND gate. If any of your input is low, your output is low. Only if both the inputs are high, your output will be high. But here in OR gate, if any of your input is high, your output will be high. Okay, this is about your OR gate and the symbol of OR gate is like this. NOT gate is nothing but a buffer. Like inverse law, if you give 0, if your input is 0, it will invert and give in your output. If your input is 0, then your output will be 1. If your input is 1, then your output will be 0. This is about our NOT gate. It is a inversion gate. It is nothing but inversion gate. It is also named as buffer. It is also named as buffer. And next one is NAND gate. The vice versa, not vice versa. In AND gate, if you add one inverter at the output, then it is said to be as NAND gate. So whatever your output for AND gate will be inverted in your NAND gate. For example, if your output is 1 in AND gate, your output will be 0 in NAND gate because you have an inverter in the output. In this circuit you can see an AND gate and in the output you have a buffer. So the inversion of your AND is said to be as NAND. Okay. Same for OR. The inversion of your OR is said to be as NOR. So in the output you have a buffer. So the inversion of your OR is said to be as NOR. Okay. Next, as I said, there are two gates like XOR and XNOR. XOR is said to be as exclusive OR, and you have one this is your truth table. This is the logic symbol of XOR. Your output is A XOR B. You can see the Boolean expression of the XOR gate. Okay. XNOR is same. In XOR you will have a inverter at the output. that is said to be as XNOR. These two gates are also named as universal gates. Okay. So this is all about our logic gates. In the next session, let us discuss about the universal gate, how it is implemented in NAND gate and NOR gate. Thank you.